The visualization wheel. So the visualization wheel is the set of concepts that was put forth by Alberto Cairo in his The Functional Art and Introduction to Information Graphics and Visualization. And it provides a number of spectrum of dimensions or categories that are useful to think about when we think about graphics and data visualizations. So there's a number of dimensions. So for example, density, and then the other side of it, the lightness. So one set are more complex and deeper dimensions or categories, and the other one is more intelligible and shallower, or at least more intelligible at first sight. So let's discuss these a little bit farther. So the first one is abstraction and figuration. So abstraction are things like boxes and charts, like a bar graph, and then the figuration are actually real world physical objects. So when you actually draw things like a bucket, when you're talking about buckets, or people when you're talking about people. The other set of dimensions or spectrum is the functionality to decoration. So functionality is just focusing on the data at hand, where in decoration is adding artistic embellishments. And then density and lightness, the more dense is the more information, that is at least more depth, that needs to be studied a little bit more careful. And then lightness is the stuff that is more visually clear. Let's take a look at an example here on how these three dimensions play out. So first, let me tell you that this is a graph of students enrolled in a online course, and in a massive online course, so you can have thousands of students. And the dimension on the x-axis is percentage of chapters accessed by the students. So each dot here is a student, and that's the unit of analysis. And on the left, on the y-axis, is adjusted grade. So there's a kind of percentage. So for example, let's pick up like let's pick some dot over here. So this student here has very few percentage of chapters accessed, maybe 5%, and then their grade is around 50. And then there's some student here, their chapters accessed about 50%, and their grade is about much higher. So is this more abstract or more figuration? I think it's clearly more abstract, right? There's no actual person being illustrated here or chapters. Functionality decoration, more functional decoration. I also see almost zero decoration. He is just focused on the functionality of showing this pattern. And there's a kind of clear pattern here, right? A lot on the top right is very dense, a lot going on here, and on the bottom left as well. So people with low chapters accessed also generally are associated with low grade. People with high chapters access associated with high grade. And then density and lightness. I think it's a little bit dense, but it's also not, because there are not that many dimensions. I think we can kind of clearly see that there is a congregation here on the bottom left, and then also another one on the bottom right, and we kind of see a positive correlation. So another set of categories here, or dimensions, that is the one of multidimensionality and unidimensional. So multidimensionality is the different aspects of phenomena or single view of items. Would you say this is multidimensional or unidimensional? Well, at least two dimensions, right? So on the x-axis we have one dimension, which is about chapters. On the y-axis we have another dimension, and actually we have another dimension here with the thousands, which is for the histogram. And the histogram is reflecting the density that we see here. So you see a lot of density, and we kind of break it up on a histogram to also visualize. And we actually have the thousands of frequency, right? The histogram is the frequency, and this is the frequency of students. So how many students are in this over here for the grade, and then here for the chapters accessed. So I would say it's multidimensional with 3 dimensions. Originality versus familiarity. Novel methods of visualization or established or understood methods. Well, it kind of depends how well you are acquainted with some of these graphs, but I would say this is in between. It's not very original, and it's not very familiar depending on the person. Novelty and redundancy. Do you see any novelty or redundancy here? Well, I see a redundancy here. If we look how the top, the axis repeats the bottom one, is the same thing. It's kind of just repeated here so we can see more clearly. And the same thing on the left and on the right. Sometimes we have graphs that have one dimension on the left and another dimension on the right, but this one is the same. So it's a little bit of redundancy here, which facilitates comprehension. Here's another interesting image where kind of perhaps intuitive, which is the wheel preferred by scientists and engineers on the left, and the wheel favored by artists and graphic designers and journalists on the right. So as you could probably guess, scientists and engineers prefer graphs that are more abstract, functional, dense, multidimensional, whereas artists and graphic designers and journalists prefer graphs that are more redundant, unidimensional, light, with decoration and figurations. The only thing that kind of differs a little bit is on the originality. So scientists and engineers prefer familiarity, whereas artists, of course, like originality. Let me talk to you a little bit about this concept of data to ink ratio. You can see more here, Dark Horse Analytics, and it's a kind of interesting and useful concept, I think, thinking about data to ink ratio. So here, let's begin with this graph here, kind of an old school graph. You may see it. You may still see these kinds of graphs, and I would say this is a very high, a very low data to ink ratio. That is, the ink is a lot of ink for very little data. So very low data to ink ratio. And the idea is to create a higher data to ink ratio, more data, less ink. So we can, first of all, remove redundant labels. Well, actually, I'm sorry, this should say probably remove the background. The brown background doesn't mean much. Now here we remove the labels and some of the borders. So we remove the border and actually remove the whole legend, because the legend doesn't really seem necessary here. You're kind of repeating because you already have the labels on the bottom. Now, we also removed some of the labels because we were just talking about calories. So calories per 100 grams, so we know that the left dimension is calories. You don't need to kind of write it again. Now we do some other borders, and we kind of lightened. Okay, here we removed borders. I'm sorry, maybe the titles are not matching entirely with the image. But we're just kind of removing ink, essentially, just removing stuff. And then remove some effectual effects, or really remove the colors here. I think the special effects remained, but I do kind of like the different colors to differentiate, but following the data to ink ratio, we would remove the colors as well if they don't seem that interesting. Now, in this example here, they kept the bacon as red, and then maybe you want to think about why would you keep something different than the other ones. And I didn't really see why they did this example, but it may be related to what you want to achieve with that graph. If you want to talk about bacon as a special kind of food, maybe you wanted to highlight it in contrast with the other ones, and you would do this. And here you do remove the special effects on this one, and also line the labels. Why were they bold? Doesn't make sense. And just remove the background, because what was the background used for anyways? Now I kind of like the background in the bar graphs, the grid lines sometimes, but they're suggesting to remove it. And then why even have the y-axis? Why don't you just put the numbers on the bars themselves? Now, this may depend on your school of thought, and there's a little bit of a subjectivity here, but probably this is better than this here, but also maybe somewhere in between might be, for example, here is also kind of good and useful, or here. I kind of prefer this one. Which one do you prefer? Anyways, okay, this is the final example. Okay, next we're going to be talking about qualities of a great visualization.